Okay, I think it's time that we begin our afternoon session as we're just after 1:30. So if you'd like to take your seats, and I'm sure there'll be plenty of opportunity for the conversations to continue later on during the day. So let me say how impressed I am at what a lively and stimulating group you are. So, and I mean that in a very positive way. I'm not going to make the faux pas that Frank did. So well, I will say I have an aunt who is a member of the U3A down in Essex, and she finds it a very valuable and worthwhile opportunity and group to engage with. So for me, I think learning should be for all age, not just for the third age. So anyway, we're moving on to our third session today, and this is where we're going to look at some of the consequences of energy in terms of development of nations and wider environmental impact. So we've got two excellent speakers lined up for you this afternoon. The first is Professor John Gluas, who you've already met, who is our DEI director. He works in our Department of Earth Sciences, and he also worked in the oil and gas industry before he came to Durham. So I invite John to give his presentation now.
Thank you, Douglas. Well, as you... Mom? Am I also holding it the wrong way around? No. I think so. Are we switched on? No. Switch on. I'm only a geologist. So I am a geologist, but I'm not going to talk much about geology now, really. I'm going to dive into the unknown and think about some of the social impacts. Clearly, as a geologist, as a scientist, though, we're not going to entirely get away from a brief description of the Earth and what it delivers for us. So I thought I was going to stand a long way back, having seen Douglas's presentation with the size of the sun and the impact that has. I'm not sure I've stood far enough back, but this is what we have to play with. This is our energy system. It either comes from the Earth or it comes from the sun, or as one of our speakers said this morning, the interaction of those two, the energy stored in fossil fuels from ancient sunlight. So this is our job lot. And I like particularly at the moment just to think about the Earth bit. The Earth is hot. It's just as well it's hot. It's hot because we've got quite a bit of thorium and uranium in the crust, and that's decaying. As it decays, it liberates heat, and that's what is keeping the Earth warm. A smaller planet like Mars might have been pretty warm at one time, Mons Olympus or Olympus Mons. Clearly there's a big huge volcano there, but it's pretty dead now. So it's just as well that we have this uranium and thorium in the Earth, because not only does it keep the magnetic core liquid and therefore able to generate the magnetic fields which keep the sun's solar wind at bay, but it also drives the whole of the planet system. And we can use quite a bit of that. In fact, I wouldn't worry too much. We've still got about 85% of the thorium left. We've only used 15% in the last 4.5 billion years or so. And it gives us this dynamic Earth. It drives the plates, keeps the Earth in motion, and ultimately affects, in fact, controls the whole of life on Earth. In terms of leaping from that energy system generated by Earth and Earth's interaction with the sun through fossil fuels, you've seen a number of versions of this particular graph already. We are hungry for energy as a species. The Industrial Revolution changed, as Adrian said, from a society which was dominated by the muscles of humans and animals, coupled, I should say, with burning a little wood, of course, and so on, to the mineral world. And basically, we began to exploit that which had been packed away millions of years beforehand. I understand now that we're consuming fossil fuels at a rate of about 20 million years worth for every year currently. We've got a long way to go, so I wouldn't worry about running out too much, but the impact of this has been quite dramatic. And the reason that we've got so hooked on fossil fuels is this chart behind me, and it was mentioned by a couple of people who asked questions. The energy density. Gavin talked about packing that gas into a 600-fold increase in, or decrease in volume. And it's the energy density which really makes a difference between the value from burning a plank of wood to that burning a piece of coal, or better still, oil or gas. We get a lot of energy. It takes a lot of carrots to get your donkey to haul the cart up the hill. It takes much less diesel to do the same. And that is why, as a species, we're so hooked, we're so addicted to energy, and why it would be so difficult to move away. The renewable energy forms, perfectly adequate, and we heard from Charlotte about the use of very low temperature water. Why heat your bath water to 60 degrees when you're going to have to put cold water in as well? But it's so easy with that burning of coal. We can do it, but we have to change the way we think a little bit. But that energy density has changed the world once its applications were really appreciated. And I would say this is a map from Google which looks at modern empires. Modern empires, I suppose in the last 2,000 years or so, this covers, or the last since the exploration by Columbus in 1492, wasn't it? Yeah, to the USA, or to the South America rather, Venezuela, Little Venice. Empires have grown, I would say, initially, it's still energy, it's still the wood, the toil, the food, until the one we heard about from Adrian. So he looked at the domestic change, the change in housing, the advent of the chimney. I'd never thought before just the social significance of that. But it also had, as he hinted to, or alluded to a little bit, a huge impact globally. That industrialization, that access to energy, created the UK, or the British Empire. From its meagre beginnings in the 15th century, when we began to foray with our ships further afield, to the point where by about 1820, we had colonies around the globe. And Acme, around about the early part of the 20th century, I would say that was driven by two things. Slightly frivolous on the second one. Coal, and the enormous amount of energy we were able to derive from that, and probably Scottish missionaries as well. But there is a correlation. It's a very good correlation. It's not entirely causal, but I think it plays out very well indeed. With coal production, this is the coal production from the UK. It peaked in 1911 with slightly over 300 million tonnes of coal per year. Carbon footprint, I should add, which matched that from Saudi Arabia at peak production. And declined since then, to the point, of course, by mid-1980s, when we no longer had a coal industry. When 2010, when I arrived here, we were importing most of our 50 million tonnes of coal we consumed per year from Russia. We're not now, don't worry too much. We now have got cheap American coal, given the advent of the shale gas industry. I think this correlation is quite important. I would say this is not the only, if you like, globally dominant force which has come out of fossil fuels. There is, of course, a whole plethora of ones who are trying to do the same now. But before we leave coal, that's just to show you what the UK was doing by the early part of the 20th century. 300 million tonnes of coal or so. It's down to almost zero now. And the only country that got anywhere close to that was the United States. Of course, they weren't the first to exploit petroleum. I remember a couple of years ago, I was president of the Petroleum Exploration Society of Great Britain, and each month you do a little newsletter item. I'm sure you read similar ones. And it was the 150th anniversary of the so-called first ever oil well drilled by the so-called Colonel Drake. It was neither a colonel, nor was it the first oil well. And I said that in the article. And I got lots of emails wanting to point out that the Trinidadians, the Romanians, had all produced oil before then. Indeed. Who was first? Scotland had the first true industry, yes, but who drilled the first oil wells? Come on, it's either one of two countries. It wasn't America, no, it was China. Either China or India, isn't it? China were drilling wells 200 BC, producing the brine and using the petroleum extracted to dry the brine to give salt. Anyway, but shortly after Colonel Drake, or the so-called Colonel Drake, drilled that well at Tootsville, Pennsylvania, what existed of the federal government in the USA did a technology comparison between whale oil and mineral oil, and they found that whale oil was inferior for lighting, heating, lubrication, and so they promoted, with tax breaks, the use of petroleum. And there, out of that, grew the petroleum industry in the USA, particularly in California to start with. If we bring that up to date, think of the major players in the world. It took me a weekend to draw this bloody graph. And I had to have two sons, both, I think, 4 degrees between them to help me get the flags in the columns. Who are the big players? Well, clearly the USA has been a major player throughout that period. These are the data from the BP charts that you saw earlier, but I wanted to discretize it. So I've looked at every year. The charts only start in the 1960s, so every year, 5 years, and then forward. Clearly the USA has always been there. I know we've had the USSR, Russia claimed recently that it didn't develop the nerve agent that was USSR, but you can see here too that whatever you like to call it, the Russian state and its predecessor have also been big players. Venezuela, I lived there for 3 years with the Arc of Stars, has been thereabouts, but truthfully they've never had anyone who could organise a drink in a pub. Not since Simon Bolivar, anyway. That was a little while ago. Saudi Arabia has been big. We see in 2000 that both the UK and Norway made it in there. In fact, just outside the top 10 a decade before was the UK. We were, for a very, very brief time, the third biggest, this is oil and gas, third biggest oil producer in the world, very, very briefly, all of which was taxed at 95%, as was the gas. That was the income we saw coming into the nation in the 1980s and 1990s. We became a net petroleum exporter in 1980, as you know who came to power. And we ceased to become a net exporter when the other you know who left power. Those were the halcyon days, driven by a petro-economy. I would say very strongly that with the right organisation, of course, and that's why I rather jokingly mentioned the Scottish missionaries, the organisation, if you're a major energy producer, inevitably you will grow in stature as a nation. And look who's coming in the last 3 decades. China. China, major oil producer. China's had to do it in a slightly different way. Its intrinsic coal resources are very big, but not too much petroleum. It's bought up companies around the world. Look in the North Sea now, and a company might be called Talisman, which is a Canadian derivative of BP, but it's owned by China. Petro-Canada became Chinese a few years ago, and so on. They've been buying petroleum resources in the ground since I came back from South America in the mid-90s. Since about that time, I remember losing out to them in several bids for acreage. I'd just like to take us to a graph, some of which you've seen already, but I want to emphasise and ask a couple of questions here. There are only 3 lines on a graph Is it 3 lines on a shirt? No, it's 3 lines. Anyway, there are 3 curves here. Saudi Arabian production, US production, and US consumption. They're obviously slightly different from the graph that you saw earlier on, and I'm not quite sure where that's derived from. It might be associated with gas. But the point is that recently the USA overtook Saudi Arabia in terms of oil production. So what did Saudi Arabia do? Or what did OPEC do? Drop the price. We're benefiting, at the petrol pump at least, occasionally, by this tussle between the 2 giants of, the non-Soviet or non-Russian piece of the petroleum production. The USA has overtaken Saudi Arabia, and in order to try and win that production back, Saudi Arabia dropped the price. The problem is that the USA has got this machine, this factory process of shale, gas, and associated liquids, which is vast. You heard Andy Applin speak first off this morning. And the problem with Saudi Arabia is, of course, although they don't say this, most of their fields like Ghawar, 200 billion barrels reserves, are actually running out. As oil fields get older, they tend to produce less oil and more water. And that's typical of the North Sea now. A barrel of oil comes with 10 barrels of water in the North Sea. As it happens, hot water you could use for geothermal, but that's another story. Saudi Arabia is in the same sort of boat as that. Ghawar was founded in 1949. And so it's a struggle for them. But to me, there's another piece of information on this graph. If you look at the separation between US demand and US production over the last decade, what happened in the USA in 2016? They voted in a president who said, US for the USA. We can do it all ourselves. We don't need to think about the outside world. Track back a little over a decade to 2003, what big global event happened in 2003? The invasion of Iraq. The gap between demand and production was as great as it's ever been. I would say that the decisions and made by not just individual presidents, but also groups of people, is influenced in a major way by this sort of chart. Unwittingly. No one looks at this and says, hang on a minute, the gap's really big, I think we best invade a country which has got a lot of oil. Well, not openly at least. And I would say, coming back to the UK case, the governments of the 1960s and 70s recognised that the coal, even though we had plenty of coal in the ground in the UK, that we were not competitive in terms of producing that at very low cost. And we went through a couple of crises, of course, and put in place, the hapless governments of the 1970s put in place the plan to develop the North Sea. And the North Sea, the very first major field on stream from the North Sea was Forties. And Forties was owned by BP. And who owned BP? They do now. The UK government owned half of BP. A secret deal brokered by Churchill at the end of during the First World War, after he'd had all the ships converted from coal to oil. We were then short of oil. He tried to do a deal with Shell, who rejected him, and eventually did a deal with Anglo-Persian, or Darcy Petroleum as it was then, who adopted the name of a German petrol selling company in Britain called BP. Yeah. Anyway, essentially, the government underwrote that North Sea development. Had it not done so, we would have taken, I think would have got there, but it would take much longer. That very first piece was underwritten. It's a little deviation now from sort of empires. We're seeing the same. On the slide which Charlotte showed, she had a town in the Netherlands called Heerlen. Heerlen has transitioned from being a coal-based economy through a period of mass unemployment to one in which they use those flooded coal mines for heat. The risk of doing that in the first instance, first of a kind, on a citywide basis was quite high. That too was underwritten by the combined Dutch and European funding. So again, I think there are stories to be heard here about the interrelationship between energy and communities and politics. And if we look at the players in G8 plus Russia, in a sense, those economies developed on the back of access to fuels. In some instances, they were limiting. Germany and latterly South Africa didn't have much access to petroleum. They had a lot of coal, and they pioneered the transition of coal products into liquid products. Not enough. Anyway, oil, gas, coal, critical to the development of society as we know it today. But let's have a look at the other side. The second law of thermodynamics says, I know, anyone from Yorkshire here? Am I allowed to say this? I know there's a couple of nudging over the border into Cleveland. You don't get out for an out. And that's what the second law of thermodynamics tells you. And so there is consequence to everything we do. If we think about some of the consequences that are well known and some which are less well known, a real pea super was a term which I remember as a child. Unfortunately, we do not see anymore. In the 1950s, the UK government recognised that the amount of particulate matter coming from coal-fired domestic fires and industry was killing the nation. And so in 1956, it introduced the Clean Air Act. It's not the only, China's got there more recently in 2014 with its equivalent. Of course, there are other environmental disasters and problems associated with the coal burning and coal mining, whether it's the acidification of the atmosphere and so-called rain, or some of the more disastrous direct effects on coal mining communities, whether it's explosions or the horrendous Aberfan, which I think was 1967, wasn't it? Yeah. Let's say anniversary was last year. But as Chris said in the first talk, rare earths, we have to mine the world to deliver so-called renewable technologies in many instances. And the one I've been working on of late is induced seismicity. When we remove fluids or solids from the ground or even inject them into the ground, we do get a reaction. In some instances, it's benign, a little bit of subsidence perhaps, but in others, not so. And in the quest for energy, we have started to induce massive amounts of seismicity. We've pulled a database together. It's called HiQuake. I wanted to call it iQuake, but someone said Apple would have something to say about that. And there are 800 cases well documented. There are probably thousands of real ones. But just a couple of examples. Which is the most earthquake-prone state in the USA? California. Yeah, obvious. San Andreas Fault. Yeah, well, it was. It's now Oklahoma because of the disposal of the fluids from the fracking industry. The Chinese, they've got that wonderful Three Gorges system supplying hydroelectricity, and they're now, because of the weighting of the water onto the earth, that has become seismically active. Curiously, and I'll return to my favourite person, the biggest effect on seismicity in the UK has been the reduction in seismicity associated with closing the coal mines. Single-handedly, the most important impact on induced seismicity in the UK, therefore, has been Margaret Thatcher. Bizarre. I don't think that was planned. But in a sense, these induced seismicity, and it's not just energy. I should just point out that if you take a look at Google Earth of the south of Spain, you'll see that it's no longer desert. It's covered in, around Almeria, it's covered in polytunnels. And to produce the tomatoes and other fruit that you love to pick up at Tesco at bargain prices, the Spanish have been drawing water from beneath the surface. The water table in Spain, southern Spain, has dropped 600 feet, and it resulted in the Lorca earthquake, which killed a number of people. You are buying blood tomatoes. But these effects are rather local, and they do pale into insignificance when compared with the amount of material we're putting into the atmosphere. And I return to this curve yet again to show the growth of emissions this time, the amount of carbon dioxide going into the atmosphere. We make it into the top 10. I originally put this together when I was over in Brazil, so that's why they're on number 15. And we do it on a per capita basis as well. We consume a lot of fossil fuel, and the result of that energy release is the production of carbon dioxide into the atmosphere. And in the last 100 years or so, the carbon dioxide levels in the atmosphere have doubled to around, we passed the rather unmagical 400 ppm level in 2015. And carbon dioxide is a powerful greenhouse gas. We've got rather more of it on Venus than we have here, but with CO2 in the atmosphere of Venus, surface temperature is about 400 degrees centigrade, and lead is a liquid. It's a problem that we need to address very quickly. And it comes back to this piece of you don't get out for out. So climate change is being driven by this increase in CO2, and that is being driven by our own desires to have comfortable lifestyles. Can we carry on like this? These are some estimates of the amount of oil and gas and coal in the ground. And we haven't used a great deal. This graph is slightly out of date, but not enough to be significant. Despite us burning it at 20 million years a year, there is still plenty of oil, gas, and particularly coal in the ground to continue to poison the atmosphere. And the rate of change of the atmosphere that we can gather from geological data, because we know this has happened in the past. We can monitor changes in the atmosphere from various fossil species, from isotopes and so on. I know the fossil record is incomplete, but as far as we can tell, the rate of change at the moment is about 10 times that we've been able to pick up from any geological systems. And so we really do need to sort things out, and I will finish on my favourite slide. Thank you.
Sorry, I was muted. Thank you very much, John. I'd like to introduce our next speaker now. John Bothwell is one of the co-directors of Durham Energy Institute. He's from our Department of Biological Sciences, and he works on biofuels, and he's going to tell us a little bit about environmental consequences of energy.
To make up for that fact that I have nothing to say. Good afternoon. I'm yet another John. There are a lot of us around at the moment. My talk's going to be much quicker, shorter, and we'll just follow up on a few things. There's two main points that I want to get across. The first is the diversity of fuels that we're looking to replace if we're moving from petrochemical to renewable. And the second is a little bit of consideration about the way in which the Earth's ecosystem works and the way in which our need for energy might affect that in the future. The first point really is we have been talking so far today mainly about energy as a number. So we've been talking about a certain amount of energy that needs to be required or maintained or delivered. And Off the top of my head, I think the UK's energy demand is something like a couple of hundred gigawatts, which is a couple of 100 billion watts. And an easy way to think about that is that at any given moment, each of us is responsible for about 100 light bulbs worth of energy. Each person in the UK walks around with a big glowing 100 light bulbs worth halo. But of course, it's not as simple as simply needing to replace a number. We have the UK's energy demand, UK's energy use, is divided up among a number of smaller sources. And just give one of the local night spots. Very, very roughly, the UK's energy demand is divided approximately equally between domestic use and transport use. And John mentioned, a couple of other people have mentioned, the idea of energy density. Now, domestic energy can come from fairly low-grade fuel because we can site the power generation plant somewhere else, burn fuel at fairly low cost, and then ship the fuel or the electricity to the domestic user. Transport fuels, on the other hand, are a much more high-grade form of fuel. In almost all cases, something that moves needs to actually carry its fuel with it. And that means that we have to have much higher grade fuels. We need to have fuels that are much higher energy densities. The reason there's petrochemical refinery up on the screen is because we don't just get energy from petrochemicals. We get a lot of other things as well. For those of you who are wearing artificial fibers, the ethylene that was used to synthesize those will have come from petrochemical feedstocks. Don't worry, there is no test, you don't need to remember this, but it's just a cartoon of the various things that we get from the petrochemical industry. Just to give some examples, the tar that's on the roads, that's one of the lower grade products. The ethylene that produces artificial fibers, the various different kinds of fuel. So it's not just a case of trying to meet an energy requirement, although that is obviously a very large part of it. If we are to move away from the petrochemical economy, we need to also start thinking about the other things that petrochemicals provide for us. Now, that leaves a bunch of questions I'm essentially going to leave open. We haven't got time to cover everything. We've heard a lot about the potential for fusion. We've heard a lot about potential for geothermal. We've heard a lot about, we haven't heard that much about the potential for wind, but there is, it is a major component of renewable energy sources. Those all have significant potential for delivering a large amount of energy to the UK. They have virtually no potential for delivering stuff, actual material. They deliver heat, they deliver energy, they deliver electricity. So there are gaps that the petrochemical economy will leave us as we move away. I'm not going to suggest particular solutions to that, just raise that as a question. Focus a little bit more on the kinds of fuel again, the energy density question. I work on biofuel. I'm going to illustrate this principle using biofuel, but the principles hold for all fuels. Biofuel can be generated or separated into a number of different kinds of fuel. Those fuels have different energy densities and different uses. They also have different costs of generation. So there's biodiesel, petrol fuel, bioethanol, which is a lighter fraction, biogas or biochar. Biogas and biochar are relatively cheap to make. We can actually economically generate energy using biomass by converting it into biogas or biochar. But it's fairly low-grade fuel, suitable for domestic heating, but not really for the higher-grade fuels on the left, which are more suitable for transport fuel, biodiesel, bioethanol. Another thing we should bear in mind is that a lot of the problems facing, we'll hear more about this, I think, in a later session, a lot of the problems facing a potential move from petrochemical to renewables are to do with the fact that our existing energy infrastructure is so very, very highly optimized for petrochemicals. The world essentially is based around the internal combustion engine. All of our cars have internal combustion engines. Our cars are expensive things. If we are to replace petrochemicals, we have to go and throw away our cars. re-engineer a lot of the power generation devices that we're currently using. Now, we heard earlier that by 79? 75, I'm sorry. So in about 60 years, we'll be working on that, but we've got to do something in the 60 years till then. And again, here's another plot which, I'm a biologist, so I don't really hold with equations or graphs. I'm much more a pictorial chap. This is a plot of the energy densities of various fuels, and you can see up at the top right, petrol, ethanol, diesel are very high-grade fuels. Those are the things you put in the car, or in the holy grail, really, of transport fuels, particularly with all the cheap holidays everybody has nowadays, is aviation fuel. So it is practically impossible to drive or to fly an airplane on renewable energy. The only real source of renewable energy that can drive a plane fast is something like biofuel, and only if you are willing to lose money hand over fist in generating the biofuel. So at the moment, the holy grail really of a lot of fuel generation technology is how to fly something renewable. And it's not a problem that we have gone a very long way towards solving. So that's the first point. The first point really is that the fuels that we need are a lot more diverse than we have been thinking about. If we are to think about a move to renewable economies, we need to think about replacing a suite of fuels rather than just a single large energy number. Point number one. Point number two is what are the consequences of doing that? Well, this has been discussed in a few lectures earlier, but history teaches us that the demand for energy is, or has been, a driver for hard conflict. This is a map of Operation Barbarossa, the Nazi German invasion of Russia in 1941, which actually, incidentally, reminds me about the story of how Greece won World War II. I was born in Greece, and one of the favourite stories that Greeks tell is the story of how Greece won World War II. The way they did that was, you will see on that map there's a reddish coloured section in the middle, which is the Nazi invasion plan. The top lobe, upper lobe, heads off towards Moscow. The bottom lobe heads down towards the oil fields in the Donbass, the Caucasus. At the time, Nazi Germany was running fairly short of fuel, and Operation Barbarossa was a two-pronged attack, first to actually decapitate the Soviet Union, but also to steal the oil reserves. A major part of the Nazi war effort was to take over the oil fields in southern Russia. Unfortunately, Italy, this operation was planned in concert with Italy. Italy was supposed to invade Greece and attack through the southern route, and the Italian invasion plans and operation was so poor that the Greeks managed to stop them from invading Greece. And that meant that Hitler had to hold off the main attack of Barbarossa for about 6 weeks to help Italy invade Greece. As the Greeks tell it, this means that the delay of the invasion of Russia by 6 weeks meant that the Germans hit the Russian winter. So the Greeks are responsible. Next time you hear Churchill speaking, it was really Greece that did it. So the demand for energy can drive hard conflict, and certainly closer to home, John mentioned 2003, the invasion of Iraq, which was, of course, nothing whatsoever to do with the oil reserves. More subtly, the demand for energy can also drive soft conflict, geopolitical conflict, social conflict. Now, that's a map of population density, the world population density, a couple of years back. There are lots of people where you would expect there to be lots of people. There are fewer people where you would expect there not to be, in the Sahara. That is likely to change. And I won't put it up, but if you look at a map of where energy is used, a lot of the time the two maps don't really correlate very well. Areas with a lot of people do not often have a very high per capita energy generation. And the world is a changing place. Brexit has taught us that, and a number of other things have taught us that. People migrate, people move. So what we are seeing now, and we will see over the next few years, and I think this will be covered in the session this afternoon, is that the